What's your dream university?
Stanford,
Oxford, LSE,
McGill,
Cambridge. What about you?
NUS。
迈向世界名校的阶梯，首选辅仁国际学校。
Okay, good morning, class. So welcome to the physics lesson. Right. So today we'll continue to learn on the topic of quantum physics. Right. So can you take out your notes? So before the start of our lesson, I would like to recap the important concept we have learned last lesson. Right. So what did we learn last lesson? Any suggestion? Photon. We learn about photon. Okay. So can anyone tell me what is a photon? 结慧?
It's a quantum of electromagnetic radiation.
Quantum of, okay.
It's an energy.
Yeah. Quantum of EM radiation. Okay, then we also know the energy, right? Energy of one photon equals to HF, then also equals to HCO lambda, right? HCO lambda. Okay, then what is H? It's a constant. What's the name of the constant? Planck constant, right? H is Planck constant, and the value is 6.63 times 10 to the power minus 34, right? Okay, this is the constant, right? Okay, so we also learn about the property of photon, right? So what is the property? Li Mei. Li Mei, what is the property of photon? What's the mass? 1.6. Photon has no mass, right? Okay, and also no change, no charge, right? No charge, and it travels at the speed of light, right? Okay, and the value of C is 3.0 times 10 to the power 8 meter per second, right? Okay. So these are the property of photon, right? So today we'll continue to learn about the experiment of photon, okay? Photoelectric effect. So turn your notes to page 6. So before we look at the experiment, so just look at the name, right? So we divide the photoelectric to two parts, okay? Photo and electric, right? So what does photo mean? Photon, right? Come from word photon, or it's about light, right? Photon. Okay. Then the electric, okay, comes from the word electron. Okay, so we know that this photoelectric effect talks about the reaction or interaction between photons and electrons, right? Okay, so let's look at the metal surface. Okay. Then what is the type of bond inside metal? Metallic bond, right? Metallic bond. Then can you tell me what's the structure of metallic bond? You have cation ions. Okay, at the center, right? Cation at the center, then surrounded by a sea of delocalized electrons, right? Okay, so so you can see the electrons are in layers. Okay, there are different layers of electrons. So when I shine some light on the metal surface, photon, okay? Then some of the electrons, okay, will be released from the surface. Okay, so, for example, these electrons may come out. Okay, this electron may come out, and this electron may come out. Okay, so this phenomenon we call it photoelectric effect. Okay, look at your notes. Okay, on page 6, in the middle, there is a definition, right? So, can someone tell me what's the definition? Wenxi? Okay. Okay. Yes. Okay. So it's the emission of electron from the surface when light of sufficient energy falls on it. So the word sufficient energy, I can also replace this by frequency, right? So why can I do that? Okay, because of the relationship, right? Because of the relationship E equals to HF. So we know that, okay, for a photon, okay, the energy proportional to the frequency, right? So we know that, okay, sufficient energy also means sufficient frequency, right? So sufficient frequency falls on the surface. Okay, so you need to remember this definition, right? And the name, we give a name to these electrons that are emitted, right? So they are called, what's the name of electron? Okay. Photoelectron. Okay. Right, so we use this term to differentiate the electrons that are inside the metal and the electrons that are emitted. Right. Okay. So next, let's look at the setup of the experiment. Right, how do we carry out the experiment in the laboratory? So we have a circuit, okay. Okay, there is a milliammeter. Okay. Then there is also a power supply. Okay. And we have a chamber. And you can see there are two plates, right, in the chamber. Okay, can you tell me what are the name of the two plates? Okay, for example, if the light shine on this surface, then this one we call it emitter, right? We call it emitter. Okay, because this is the one that emit the electrons. So electrons are emitted. Then can we see these electrons? No. Why? Why we cannot see the electrons? Because they are very small, right? So how do we know whether electrons are emitted? How do we know? Okay, we need to check from the emitter, right? So we need to make sure the electrons that they are emitted, they reach the collector, right? On the other side, we call it collector. So for it to reach the collector, we need to apply a potential difference, right, across the plate, right? So what is the potential difference here? Positive or negative? This side should be positive, right? This side should be negative. So the electrons will be attracted to the collector, right? Okay, so they move to a collector. Okay, then the current will flow. Okay, so from the ammeter reading, if it shows a non-zero reading, then it means photoelectric effect occurs. Okay, if the ammeter shows 0 reading, then it means photoelectric effect does not occur. Okay, any question on this? Okay, then for this chamber, okay, we call it, how do we call it? Called evacuated tube. Okay, so what does it mean? What is the inside? Vacuum, vacuum. So vacuum means there is nothing inside the evacuated tube. Why do we need to use vacuum? If there is no vacuum, okay, there will be air inside the tube. As a result, yes, as a result, the electrons, the photoelectron may collide with the M molecules, right? So they may not be able to reach the collector. Okay, so that's the reason we use a vacuum evacuated tube. Okay. So let's look at page 7. Okay, in the middle there are some blanks for you to fill up, right? So explanation of photoelectric effect. Okay, first one, light consists of photons, right? Light consists of photons, and the higher the frequency, the higher the energy, right? The formula is E equals HF. Okay, then one single photon collide with one electron, right? The relationship is 1 to 1, right? You cannot have 2 to 1 or 1 to 2. That's not possible, right? One electron to one photon, okay? And the photon will give all of its energy to that electron, okay? Can you give half? Not possible, right? For photon, right, the definition is the quantum of electromagnetic radiation. So it's the smallest packet of energy. So you cannot give half, right? It's already the smallest. Okay, so either you give all or you don't give, right? You cannot give half. Okay. The next one, okay, since the electrons are held by attractive electrostatic force to the atom, okay, to escape from the metal, the electron must do a certain amount of work, okay, to remove the cell from the surface. This work is also known as the work function of the metal. Okay, so next let's look at this term, okay, work function. Okay, work function, we use the letter phi, right, to represent this quantity. And the definition is the minimum amount of energy required to remove an electron from the metal surface. Okay. So just now we already discussed for metal, okay, there is metallic bond inside the metal, right? And in order to remove the electron from the metal, okay, you need to do some kind of work, right, to break the metallic bond. Okay, and this process takes energy, right? Okay, so I use an analogy. For example, this marker pen, right? So in order to remove the cap from the marker pen, okay, I need to do some work, right? I need to do some work. There is a minimum amount of work needed for me to remove the cap from the pen, from the marker, right? So if the energy is not enough, what will happen? Okay, it cannot be removed, right? No matter how many times I try, okay, I cannot remove the cap because energy is not enough. Okay, so how? I just try once. Okay, enough energy, then the cap will be removed. Right. So this is similar, okay, to the photoelectric effect. Right. You need to do a certain amount of work, right, to remove the electron from the metal surface. Okay. Next, let's look at this, the different electrons in the metal. Okay. So there are electrons at the surface. Okay. For example, this one. Okay. This is electron number 1. Okay. It's at the surface of the metal. Okay. Then this is electron number 2, right? It's at the second layer of the metal. Okay. Then you have this electron at the third layer of the metal. Okay. Then can you tell me which electrons needs more energy to be released, or they require the same amount of energy to be released? Thông Yao? The third one. Okay, can you tell me why the third one requires more energy? Okay, this electron is closer to the cation ions, right? It's closer to the cation ions, so it means stronger attraction, right? Stronger attraction. So if attraction is stronger, then you need to do more work, right, to remove the electron from the metal, right? So this one, okay, let me write down. Okay, this one requires more energy, right? So work done, okay, for 3 is larger than work done 2. Okay, is larger than work done number 1. Okay. Then let's come back to our work function definition. Okay, so the work function definition says that it's the minimum amount of energy, okay, to remove an electron. Okay. Then can you tell me which work done is the work function? Which one is the work function? Okay, work done number 1, right? This is the work function. Okay, because it has a surface, right? So it requires the minimum amount of energy to be removed. Okay? So let's look at page 7, right? At the bottom, there is a table. Okay, first one, okay, when the photon energy is just equal to the work function, then what will happen? Okay, the energy is just sufficient to release 1 photon from the surface of metal. Okay, so in the case of a marker, okay, look at the marker pen, I just remove the electron. Okay, so actually the cap now is not attached to the marker, right? But it does not move, just release. Okay, so this is the first case. Okay, for the second case, okay, energy of photon is less than work function. What happens? Okay, nothing will happen, right? No electrons are emitted, okay, because energy is not enough, right? No matter how many times I try, right? If the energy is not sufficient, the cap will not be removed. Okay. Then the last one. Okay. When the photon energy is larger than work function, the energy is enough to release the electron. Okay. Then the rest energy or the excess energy will be used to move the electron, right? Okay. It will be in terms of the kinetic energy, right? It will be in terms of kinetic energy. So what is the principle behind this phenomenon? Can you tell me? What is the name of the principle behind this phenomenon? Yes, okay. Principle of energy conservation. Okay, principle of energy conservation, right? So the supply of energy is from the photon, right? Then some energy is needed to remove the electron, okay? Then the remaining energy will be the kinetic energy of the electron, right? So you can write a word equation. Energy of photon equals to, okay, if we write, okay, minimum work done, okay, then this one will be, okay, maximum kinetic energy, right? Maximum kinetic energy. Okay. So we can write, okay, an equation based on this definition, right? So energy of photon, HF. Okay. So minimum work done is the work function, right? The maximum kinetic energy is the half m v0 squared. Okay. And this mass is the mass of electron, right? So what is the value of the mass of electron? Can you remember? 9.11 times 10 to the minus 31 kg, right? Okay. Okay, so turn to page 8. Okay, so on top of page 8, right, we have the definition of work function. Right? Minimum amount of energy needed to remove an electron from the surface. Okay, you need to remember this definition. Okay, and work function depends on, what does work function depends on? The type of metal, right? The type of metal. You know that a different metal, okay, the magnetic bond have different strengths, right? Right. So you know that. Okay. So depends on the type of metal. Okay, so I give you a few examples. For example, 5 of zinc, okay, 5 of calcium, and 5 of sodium. Okay, can you make any guess which one is larger? Is it like this or like this? Which one has the highest work function in these 3? Zinc, yes. Okay. So it will be like this. Okay. Of course, the value of work function will be given in the exam, right? Or they will ask you to calculate based on the information, right? So you need to take note, right? It depends on the type of metal. Okay, let's look at example 8, right, on page 9. Okay, can you spend some time to try the example? Okay, example 8, part 8. Okay. By reference to photoelectric effect, state what is meant by work function of a surface. Okay, so this is about the definition, right? So it's the minimum amount of energy required, or you can say needed, to remove an electron from the metal surface. Okay. Part B. Okay. Light of wavelength 540 nanometer. Okay, they give you a wavelength. Okay, is incident on a metal surface having a work function of 2.5 eV. Okay, the question asks, determine why the electrons are emitted from the surface. So look at this, right? The work function is in eV. So we need to convert the units, right, to joule first. Right? You can convert the unit to joule first. So how to convert? 2.5 times 1.6 times 10 to the minus 19. Okay. So can you tell me what's the answer? Hmm? 4 times 10 to the minus 19. Okay, very good. Okay. The next, what shall we do? Okay. Xiaomo, what shall we do? E equals hc over lambda to find the energy of a photon, right? We need to find the energy of the photon. So E equals to hc over lambda. Okay, so sub in numbers 6.63 times 10 minus 34 times 3.0 times 8 over, okay, nanometer, right? Convert the units, 540 times 10 minus 9. Okay. Then we get another number, right? So 3.68 times 10 to the minus 19 joules. Okay. Then the last step, we need to compare these two values, right? So compare the value of photon and the work function. So what can we tell from these values? E is less than work function. So what will happen? No photoelectrons, right? Because the energy is not enough. Right? Okay, we have no photoelectrons. Okay, let's move on. Okay. Okay, turn to page 10. Okay, on page 10, we will introduce another new term. It's called threshold frequency. Okay, we use F0 to represent threshold frequency. Okay, what does it mean by threshold? Can anyone tell me what does it mean by threshold? It's like a boundary, right? If this is the threshold, then below, okay, there is one outcome, right? It's larger than this, there is another outcome. This is called the threshold. So, so here, right, in this photoelectric effect, right, how do we define this threshold frequency? Okay. Just now we can see, right, work function, it defines the minimum amount of energy to remove the electron, right? So from this formula, okay, we know that if there is a minimum energy, okay, then there is a minimum frequency, right? Okay. So that's the definition of threshold frequency. So we define it as the minimum frequency of photons, right? Of photons. Okay, to remove an electron from the metal surface. Okay, so you define minimum frequency, right? This one is minimum energy. Okay, but you can see the second part is the same, right? Okay. So then, can someone tell me what's the relationship between F0 and the work function? Okay, work function equals to HF, right? This is the minimum energy, minimum frequency, right? So we can relate them. Phi equals to HF0. So what can we conclude from this? If the frequency is less than the threshold frequency, then what will happen? No photoelectron, right? Okay. Then if frequency is larger than F0, then there will be photoelectric effect. Right? Electron will be emitted. So can you try to calculate the threshold frequency of this? Okay. So in example 8, the question tells us about the work function. Right. So how to calculate the threshold frequency? Use this formula, right? So F0 equals to phi over H. Okay, phi we need to use the 1 in joule, right? 4.0 times 10⁻⁻19 over 6.63 times 10⁻34. Times hertz. Okay. So this is the threshold frequency of this particular metal, right? Okay. Then there is another term similar to threshold frequency, right? We call it threshold wavelength. Lambda 0. So can someone tell me what's the definition of threshold wavelength? Using this one as a reference.
The minimum wavelength of photons to remove electron from the metal surface. The minimum wavelength required of photons.
The rest of class, do you agree? Maximum? Maximum or minimum? Y maximum. Okay. C equals to F lambda, right? So we know that C is a constant. So F0, lambda 0. So we know that F0 is the minimum, right? Then lambda 0 will be maximum, right? So how do we define the threshold wavelength? Try again. Try again. It's the maximum wavelength.
Of photons to remove an electron from the vector surface.
Needed. The last part is the same, right? To remove an electron from the surface. Okay. Then can someone help me to calculate the threshold wavelength of this metal? Use this. Okay, what is the solution? 3.0 times over 8 over 6.03 times over 10 over 14. Mission? Times 10 over minus?
Minus
7, right? Meter. So we convert this to nanometer, it will be 490 nanometer, right? Okay, so what is the wavelength of the light initially? Okay, look at the question. The initial lambda is 540, right? Okay, we can see that the threshold the wavelength is larger than the threshold wavelength. So will the electron be able to be released? Is it possible? No, right? Because here we define as the maximum wavelength. Right? The maximum wavelength is 490. So now you have 540. Okay, the electrons will not be able to emit. Okay. So to conclude, right, we have 3 ways to check whether an electron can be emitted from the surface. Okay, so the 3 ways, okay, we can check the work function. Okay, the energy must be larger than work function, right? Okay, we can check the threshold frequency. The frequency must be larger than the threshold frequency, right? And we can also check the threshold wavelength. The wavelength must be smaller than the threshold wavelength. Okay? Okay, so that's the end of our lesson, right? So go back, try the example 9, right? And we will discuss next lesson. Okay, thank you.